Grace and peace to you, and welcome back to my second video on travel graphs. This is Donald Siami, author of A Hidden Mathematical Genius Within Revealed. Okay, so here we have the diagram, and we can see that this diagram started from rest and moves at a constant acceleration until it reaches a speed of v meters per second, that is for 10 seconds. Then from 10 to 30, that is for 20 seconds, it maintains a speed of v meters per second. Then it started retardating or decelerating, that is from v meters per second to 0 at 40 seconds. First question A. Find the speed v the particle reached if its acceleration was 2 meters per second squared in the first 10 seconds. Okay, so here we assume that we are solving for acceleration in the first 10 seconds. So use the same formula. We'll say acceleration is equal to final velocity minus initial velocity over time taken. Okay, now we are told that acceleration in the first 10 seconds was 2 meters per second. So here where there is a, you put 2. So you say 2 is equal to v, that is final velocity. Even here final velocity is v, so you say v minus initial velocity. It started from rest, that is a 0, so minus 0 over time taken is 10. So here we can see that we have a fraction this side, so even here should be a fraction, so you say over 1. Okay, we know that v minus 0, it's v, then we can cross multiply. So 1 multiplied by v, you get v is equal to 2 multiplied by 10, you get 20. So v is equal to 20 meters per second. So that is A. We go to B. So B, given that the total distance covered was 750 meters, find the value of t in the diagram. So here we are given total distance traveled, and we are looking for t. Okay, so I said distance traveled is just the area of the covered shape, or you just find the area under the graph. So it's total distance. So here you can see that this shape is a trapezium. So you just find area of a trapezium. So that is B. So area is equal to, it's half A plus B multiplied by height. Now we know that total distance is 750 meters. So where this A, you put 750. So we have 750 is equal to 1 over 2. A will be from 10 to 30. So that is 20. So we have 20 plus B, that is the base from 0 to t. So there is t. Then height is from 0 to v, and we have calculated v to be 20. So where there is h, you put a 20. So there is 20. So you have 750 is equal to 2 can go in 20, that is 10. So we have 10, then in brackets 20 plus t. Okay, so we are solving for t. So here we can divide out a 10 to both sides of the equation. You can say over 10, and this side over 10. Okay, So 10 and 10 will cancel out. We remain with 20 plus t. Okay, so we have 20 plus t is equal to 750 divided by 10. A 0 and a 0 will cancel out. So that is 75. So we have 20 plus t is equal to 75. Okay, now for us to remain with t this side, here a 20 will come this side. Here it is a positive 20. This side it will be a minus 20. So we have t is equal to 75 minus 20. Okay, so what is 75 minus 20? Yes, we get 55. So t is equal to 55 seconds. Okay, we go to the last question. What was the speed at 40 seconds? Okay, so speed at 40 seconds. So we assume that 40 is somewhere there. Okay, so what you do is first to look for acceleration or retardation at this along this journey. We know that acceleration is the same at any point. Okay, so we need to find acceleration along this journey. So you say acceleration is equal to v minus u over time taken. So acceleration is equal to final velocity here, it's a 0. So we have 0 minus initial velocity. It started at v, and the v we know that it's 20. So 0 minus 20 over time taken, it's from 30 to t, and we know that t is 55. So that should be 55 minus 30, and 55 minus 30 you get 25. So over 25. So we have a is equal to 0 minus 20, that is negative 20 over 25. So this one can be simplified. We know that the highest common factor for 20 and 25, that is 5. 5 in 20, that is 4, and 5 in 25, that is 5. So acceleration there is negative 4 over 5. So I want to find speed at 40 seconds. So that is from 30 to 40. And you know that from 30 to 40, then time will be 10. That is 40 minus 30, that is 10. So t should be 10. And we know that speed or velocity is equal to u plus at. u plus at. So we have v is equal to initial velocity. We know that it started at v meters per second, and the v is 20. So we have 20 meters per second plus acceleration we have negative 4 over 5, and the time that is 10. Okay, so we have v is equal to 20 meters per second. Here there is positive, and inside there is a negative. Positive multiplied by negative, you get negative. So we have minus. Then 5 in 10, that is 2. 2 multiplied by 4, you get 8. So minus 8 meters per second. So v is equal to what is 20 minus 8? Yes, you get 12. So v is equal to 12 meters per second. So speed at 40 seconds is equal to 12 meters per second. So this is how you perform calculations with regards to travel graphs. Thank you so much for your time.